Hi, my dear student friends. Welcome to ACE Engineering College YouTube live session, which is meant for revision series for university examinations. And this is a continuous class for the previous ones, that is Laplace transform. So, in the previous class, we have what properties of Laplace transform, that is a change of scale property. So, on change of scalar property, L inverse of f bar of s is equal to f of t, then L inverse of f bar of a is equals to 1 by a f of t by a. Okay. So, this actually came from change of scalar property of Laplace transform. Okay. So, now let us see how the problem we solve here, right. So, here L inverse of s into s square plus 1 whole square is equal to 1 by t f of t dt, 1 by 2 t sin t. Then L inverse of 8s by 4s square plus 1 whole square. So, using this by inverse Laplace, by change of scale property, how we are going to evaluate. See here L inverse of s by s square plus 1 whole square is equals to 1 by 2 t sin t. Okay. If I take L inverse of, if it is like f bar of s, L inverse of f bar of s, then it becomes f of t. Then it becomes L inverse of f bar of s means f of t. Now I am taking L inverse of 8s. 8s means 8s by 4s square plus 1 whole square. Okay. So, from this 8s I am taking 4 I am taking common, then it becomes 2. Okay. And here, otherwise I will write this in the next step, 8s, which is equals to L inverse of 8s means here it is not erasing, it is not getting erased. So, here I will take 4 into L inverse of 2s by 2s whole square plus 1 whole square. Okay. Means L inverse of 8s by 4s square plus 1 whole square is equals to 4 into L inverse of 2s by 2s whole square plus 1 whole square. Means L inverse of f bar, in the place of f bar of s we are having like f bar of 2s. L inverse of f bar of 2s, this is f bar of 2s. So, in case of f bar of 2s, we have the form that 1 by a means 1 by 2 f of t by a, 1 by a into f of t by a. See, f bar of a is equals to 1 by a into f of t by a. T by a means here 2, f of t by 2, which is equals to 1 by 2 f of t is what? 1 by 2 into t into sin t. F of t by 2 means 1 by 2 into t by 2 into sin t by 2, sin t by 2. And here multiplication by 4 is there, that I am writing here, Okay. This 4 get cancelled. So, then left by, which is equals to t by 2 sin of t by 2. This is Laplace transform of, means inverse Laplace transform of 8s by 4s square plus 1 whole square is equals to t by 2 sin of t by 2. right? Next property, Laplace transform of derivatives, means L inverse of f bar of s is equal to f of t, then L inverse of nth derivative of f bar of s equals to minus 1 whole power n into t power n into f of t. Okay, so under this we see the problems. So L inverse of log of 1 plus 1 by s square, Laplace transform derivative, inverse Laplace transform derivatives used for finding inverse Laplace transform logarithms or cot inverse, sine inverse for such type of functions. To find inverse Laplace transform functions, we apply inverse Laplace derivatives, inverse Laplace transform of derivatives concept you apply. Okay, now here I am taking let f bar of s equals to s square plus 1 by s square, because log of s square plus 1 by s square. So this I am taking f bar of s. So for for finding inverse Laplace transform logarithmic functions by direct methods is not possible. So I am applying inverse Laplace and derivatives I am applying. So f bar dash of s means which is equals to, we can also write this as log of s square plus 1 minus log of s square. We can write like this. So now its differentiation I am writing here. So it is 2s by s square plus 1 minus 2s by s square. Okay, f bar dash of s. So here s's get cancelled, only 2 by s will left. That is 2, if I bring common, s by s square plus 1 minus 1 by s. This is f bar dash of s. Okay. Now inverse Laplace transform I am taking. L inverse of f bar dash of s equals to L inverse of 2 into s by s square plus 1 minus 1 by s. L inverse of f bar dash of s is minus 1 into t into f of t. Laplace transform of derivatives gives minus 1 into t into f of t, means minus 1 whole power 1, as we have first derivative, which is equals to 2 into L inverse of s by s square plus 1 minus L inverse of 1 by s. Okay, so then which is equals to minus t into f of t minus t into f of t is equals to 2 into L inverse of s by s square plus 1 is cos t. L inverse of 1 by s is 1, which are means standard formula. L inverse of s by s square plus 1 minus L inverse of 1 by s is, L inverse of s by s square plus 1 is cos t, and L inverse of 1 by s is 1. It is a standard formula. So then from this f of t equals to, if I bring minus t that side, cos t minus 1 by minus t, which is equals to 2 into 1 minus cos t by t. This is f of t. Okay, means I have taken this as f bar of s, means L inverse of, I took this as f bar of s, no? L inverse of f bar of s is f of t, means L inverse of log of 1 plus 1 by s square is equals to 2 into 1 minus cos t by t. Okay, this I am taking as f bar of s. L inverse of f bar of s is f of t. So that is 2 into 1 minus cos t by t. Okay. Next sum. L inverse of, even this also similarly you can do. F bar of s equals to, I take as log of s plus 1 by s minus 1, which is equals to log of s plus 1 minus log of s minus 1. This is f bar of s. Now I am just taking derivative because I cannot evaluate inverse Laplace transform of logarithms directly. So I am going for inverse Laplace transform derivatives concept. So log of 1 by s plus 1 means 1 by s plus 1 minus 1 by s minus 1. Now take inverse Laplace transform on both sides. Then L inverse of f bar dash of s equals to L inverse of whole. By linearity property I can write this as directly, I am writing that 1 by s plus 1 minus L inverse of 1 by s minus 1. Directly I am writing this step. Actually L inverse of this totally I have to write. So I am directly writing as per the linearity property. So L inverse of f bar dash of s means minus t into f of t, because it is a first derivative. If it is second derivative, minus 1 whole square into t square into f of t. Okay. So then which is equals to L inverse of 1 by s plus 1 is e power minus t minus e power t. So then f of t equals to e power minus t minus e power t by minus t. Okay. So then f of t equals to e power t minus e power minus t by t. So f of t means L inverse of, what is f of t? L inverse of f bar of s. F bar of s means log of s plus 1, log of s plus 1 by s minus 1 is equals to e power t minus e power minus t by t. Right? It's like this. Even this, it's very important. Such type of means this type of problems most frequently asking in university examinations. So here similarly f bar of s, you assume for cot inverse you assume f bar of s. So inverse Laplace transform we cannot evaluate directly. So take its derivative. Derivative of cot inverse is minus 1 by s square plus 1. Now take inverse Laplace transform on both sides. Then minus L inverse of 1 by s square plus 1. Okay, L inverse of f bar dash of s is minus t into f of t. Minus t into f of t. Minus L inverse of 1 by s square plus 1 is sin t. So minus minus get cancelled on both sides. Then f of t equals to sin t by t. By t. F of t is means L inverse of f bar of s, where f bar of s is cot inverse. Cot inverse s is equals to sin t by t. Okay. Even this sum also you can do in a similar way. Let f bar of s is equals to log of s square plus 4 minus log of s square plus 9 I am writing. Log of a plus a by b equals to log a minus log b. So f bar dash of s. So 2s by s square plus 4 minus 2s by s square plus 9. Now you take L inverse on both sides. So L inverse of f bar dash of s equals to, if I take 2 common, then you can take L inverse separately for a different means for the terms, minus L inverse of s by s square plus 9. Okay. So here 4 means 2 square, here 9 means 3 square. So what we write here, L inverse of f bar of s means minus t into f of t is equals to 2 into L inverse of s by s square plus 2 square is cos 2t minus cos 3t. So f of t equals to 2 into cos 3t minus cos 2t by 2 by t, sorry, by t. So where f of t means L inverse of log. So that is therefore L inverse of log s square plus 4 by s square plus 9 is equals to what? 2 cos 2 into cos 3t minus cos 2t by t. Okay. Like this. Next, even this also, I am taking a bar of s equals, means here we can do directly. What I will do here now? I will do, for this I will take different approach. L inverse of s plus 3, this s square plus 6s plus 13 whole square I am writing as s plus 3 whole square plus 4 whole to the power whole square. S plus 3 whole square plus 4 whole square. So here we have s plus 3 here. So here s plus 3 and here also s plus 3 we have, na? So I am applying second shifting theorem, means the first shifting theorem property I am applying, that is, which is equals to L means e power minus 3t L inverse of s by s square plus 4 whole square. First shifting theorem property I have applied, where s plus 3 shifted to s by taking out my e power minus 3t by first shifting theorem. Okay. Now, which is equals to e power minus 3t. So here what I will do now, L inverse of, I just make some means some calculation, means some arrangements. I am just multiplying by minus 1 by 2 and means I am multiplying by minus 2 and dividing by minus 2 into s square plus 4 whole square. I just multiply by minus 2 and divide by minus 2, right? So now which is equals to e power minus 3t, I will bring minus 1 by 2 outside, so by 2 followed by minus L inverse of this minus 2s by s square plus whole square I can write as d by ds of 1 by s square plus 4, you can write. L inverse of d by ds of 1 by s square plus 4, we can write. So which is equals to e power minus 3t by 2 followed by minus L inverse of if I take this as f bar of s, d by ds of f bar of s means f bar dash of s you will get, no? F bar dash of s, where f bar of s equals to 1 by s square plus 4 means 2 square. Okay, is equals to minus e power minus 3t by 2 L inverse of this I am writing by f bar dash of s, which is equals to minus e power minus 3t by 2. This totally becomes as minus t into f of t. by Laplace transform of derivatives. where f of t is L inverse of 1 by s square plus 2 square now, where 1 by s square plus 2 square is f bar of s. Its inverse Laplace transform becomes f of t. So which becomes sine 2t by 2. Means inverse Laplace transform of 1 by s square plus 2 square is sine 2t by 2. So that I am going to substitute here. Okay. So which is equals to minus e power minus 3t by 2 into minus t into f of t is sine 2t by 2. So now you multiply minus into minus plus. So t into e power minus 3t by 4 into sine 2t. So this is inverse Laplace transform of this. For this problem I took separate means different approach. This I wrote I just wrote in terms of s plus 3. I made that s plus 3 into s by applying first shifting theorem. Then I convert into differentiation of some function by multiplying by minus 2 and dividing by minus 2. That is, this is converted into differentiation of 1 by s square plus 4, which looks on f bar dash of s, and f bar dash of s inverse Laplace transform is minus t into f of t, where f of t is inverse Laplace transform of f bar of s, where f bar of s is 1 by s square plus 2 square, whose inverse Laplace transform is f of t, that is sine 2 by 2, sine 2t by 2. That I substituted. Right? So this is the approach you have to see. Next, Laplace transform of integrals. Inverse Laplace transform of s into infinity f bar of u du equals to f of t by t. So this is the property we are, means these are properties I have drawn from Laplace transform of standard functions only, Laplace transform properties only, properties of Laplace transforms. We have drawn inverse Laplace transform properties, right? Now I am going to evaluate integration of 0 s to infinite log of u minus 1 by u plus 1. So actually L inverse of f bar of s, L inverse of integration s to infinite f bar of s f bar of u, like that you take f bar of u du equals to f of t dt, f of t by t. Okay, f of t by t. So where f bar of u means, here f bar of u means what? I am taking f bar of u as f bar of s, because here integration over s to infinite, if I write f bar of s, it looks odd. So for convenience, we are representing f bar of s in the place of f bar of s. In the place of f bar of s, we are writing f bar of u. Right. Now here, so what is f bar of s? Log of u minus 1 by u plus 1. Okay. Now we have to evaluate f of t. You have to evaluate f of t from this. But I cannot evaluate inverse Laplace transform directly for logarithms as we did in previously. So, yes. So here I will apply differentiation. That is log of s minus 1 by s plus 1 means log of s minus 1 minus log of s plus 1. This is f bar of s. Now differentiate f bar of s, then 1 by s minus 1 minus 1 by s plus 1 you will get, and take inverse Laplace transform. Here you can evaluate easily. So then L inverse of f bar dash of s equals to, I am separately applying inverse Laplace transform for the terms. To the terms here I am separately applying, directly I am writing that, okay, as per the linearity property. So L inverse of f bar dash of s is minus t into f of t as per the Laplace transform derivatives rule. So L inverse of 1 by s is e power t minus L inverse of 1 by e power plus 1 is e power minus t, and from this f of t equals to e power minus t minus e power t by t. This you will get. So therefore integration means L inverse of integration over s to infinite log of u minus 1 by u plus 1 du equals to f of t by inverse Laplace transform of integrals. What is f of t here? E power minus t minus e power t by t means by t square you will get. That's all. Okay, like this problem you can do. Next, multiplication by s. If the inverse Laplace transform of multiplication by s to a bar of s, in such case derivative of f of t will get. Okay, so now let us see this one. L inverse of s square into 1 by s minus 3 whole square, which is like, see, L inverse of s into a bar of s is derivative, first derivative. That is what I have shown, f dash of t. If it is L inverse of s square into a bar of s is going to be f double dash of t, means 2 times you have to perform differentiation. Here s square is there, na? So for that you have to perform 2 times differentiation. Means first, means here d square by dt square of L inverse of 1 by s minus 3 whole square. D square by dt square means 2 times derivative. F of t means f dash of t means d by dt of f of t. F double dash of t means second derivative of f of t. What is f of t? L inverse of 1 by s minus 3 whole square is f of t. That we have to find. So which is equals to d square by dt square of, so this is by first shifting theorem, 1 by s minus 3 whole square we can write as e power 3t L inverse of 1 by s square we can write. Okay, here I cannot directly evaluate applying first shifting theorem. So this 1 by s minus 3 whole square is going to be 1 by s square by e power 3t, by taking e power 3t from L inverse. So now which is equals to d square by dt square. Of course you need to write like this, you need to write. So then e power 3t, L inverse of 1 by s square is t. Okay, now you have to differentiate. So first time differentiation, one time, which is equals to here right. So which is equals to d by dt of so one time I am doing differentiation, one d by dt also left over. So e power 3t into t, UV rule. So e power 3t in differentiation 3 into e power 3t into t plus, and e power 3t you write as it is and t differentiation 1. So first time differentiation, one time differentiation done. Again you differentiate d by dt of this 3 into, again e power 3t into t differentiation 3 into e power 3t into t plus e power 3t into 1. Okay, means differentiation of this I have evaluated. Now differentiation of this plus differentiation of e power 3t is 3 e power 3t. Okay, so which is equals to 3 into 3, 9 e power 3t into t plus 3 into e power 3t plus 3 into 3 e power 3t is going to be 6 into e power 3t. Now from this you take e power 3t common, e power 3t and 3 followed by 3. If I take common, so 3t plus 2 will be left. So therefore, the Laplace transform of, means inverse Laplace transform of s square by s minus 3 whole square is equals to 3 into e power minus 3t into 3t plus 2. That's all. Okay. This is multiplication by s. Next, division by s. See, L inverse of f bar of s is equal to integration 0 to t f of u du, division by s. This sum, division by s. L inverse of f bar of s by s equals to integration 0 to t f of u du. So this is very important sum which was asked, which was means this sum was repeating so many times. It was repeated so many times. Here I am taking L inverse of 1 by, means here I am multiplying by minus 2s by s square plus a square whole square. For the previous sum, how I took the alternate arrangements, no? Similarly, I am multiplying by minus 2 by minus 2s and dividing by minus 2s. Okay, so this 1 by minus 2 I will bring out, minus 1 by 2 L inverse of 1 by s, and this totally becomes as d by ds of 1 by s plus s square plus a square, we can write. Okay, so the given sum I am just writing like this, and minus 1 by 2 I am bringing outside, so 1 by s will be left, d by ds of. So which is equals to minus 1 by 2 L inverse of, if I take this as f bar dash of s by s, f bar dash of s by s. So which is equals to minus 1 by 2 by s means what? What is the property we have? By s means 0 to t f of u du, na? So here integration 0 to t L inverse of f bar of s, this we write in terms of u, in the place of t I will just take u for the purpose of evaluating integration into du. So this total I am taking as f of u. Actually f of t you will get, means minus t into f of t you will get, that I am taking as f of u as per the given formula. Okay, so here f of u, no? So here f of u means L inverse of f bar dash of s, So here I have to find L inverse of f bar of s here, where now, so here L inverse of f bar dash of s is equals to actually minus t into f of t by Laplace transform of derivatives, minus t into f of t. Here L inverse of f bar dash of s equals to minus t into f of t. Means here L inverse of, what is f bar dash of s here? Here d by ds of 1 by s square plus a square. So minus t, f of t means L inverse of 1 by s square plus a square. Because this is f bar of s, d by ds of f bar of s is f bar dash of s I took. So f of t means L inverse of f bar of s, where f bar of s means 1 by s square plus a square. So which is equals to minus t into L inverse of 1 by s square plus a square is sin a t by sin at by a. So this is what L inverse of that. So this we are representing by here f of u means what? Minus u into sin au by a. So that I will take here. So in the place of this, f of u minus u sin au by a. How this k means? From f of t. How f of t evaluated means? How this, not f of t, this is L inverse of f bar dash of s. This is L inverse of f bar dash of s. This L inverse of f bar dash of s is integrand part. So that I am going to use. Okay. So which is equals to minus 1 by 2 integration 0 to t. So this is f of u. F of u is minus u sin au by a into du. So you bring out minus into minus plus. So 1 by 2a it becomes integration 0 to t u into sin au into du. Now it's integration by uv rule. Okay. So u into integration of sine is minus cos au by a minus u differentiation 1 minus cos a integration is minus sin au by a square. Means this term integration is cos au integration is sin au by a and followed by minus and followed by a. So becomes minus sin au by a square over the limits 0 to t. So which is equals to 1 by 2a. Now you substitute the limits. For upper limit it is going to be minus t cos at by a minus into minus plus sin at by a square minus, for lower limit this is going to be 0, this is going to be 0. U is there now. U means 0. 0 into anything is 0 and sin 0 is 0. So 0. So now if I multiply, if I take a square as LCM, then it becomes 1 by 2a cube into sin at, okay, into sin at minus at cos at. So this is what? Inverse Laplace transform of 1 by s square plus a square. Inverse Laplace transform of L inverse of 1 by s square plus a square whole square. Okay. See, inverse Laplace transform 1 by s square plus a square whole square. Right. Now he is asking us what is the inverse Laplace transform of, the question is, even also find 1 by L inverse of 1 by s square plus 1 whole square. So L inverse of 1 by s square plus 1 whole square. So you see here, in the place of a we have 1. So substitute a by 1. 1 by 2 into 1 cube is going to be 1 by 2. 1 by 2. 1 by 2 into, so sin at means sin t minus cos at means t, cos at means cos t. Just substitute a by 1 in this. You will get inverse Laplace transform 1 by s square plus 1 whole square. So this is another, means inverse Laplace of inverse Laplace transform of division by s, right? Even this also L inverse of 1 by s minus 1 whole square by s, I am writing, means L inverse of f bar of s by s. L inverse of, so here f bar of s by s, which is equals to integration 0 to t f of u du. Okay. So what is f of u here? F of u is nothing but f of t. F of t is evaluated by L inverse of f bar of s. So here f of t equals to L inverse of f bar of s. L inverse of f bar of s. F bar of s means 1 by s minus 1 whole square. So L inverse of 1 by s minus 1 whole square. Okay, which is equals to e power t L inverse of 1 by s square, where s minus 1 shifted to s by taking e power t from L inverse by first shifting theorem. So which is going to be e power t into L inverse of 1 by s square is going to be t. So f of t is equal to what? F of t is equal to what? F of t equals to e power t into t. So then f of u equals to what you get? F of u equals to t into e power t. So this is f of u equals to u into e power u. U into e power u. Okay. So now I am going to apply, which is equals to integration 0 to t u into e power u du. So then u into integration of e power u is e power u minus u differentiation 1 e power u integration is e power u. So over the limits 0 to t. So for the upper limit t into e power t minus e power t. For the lower limit this term is 0, this is going to be minus 1. So which is equals to t e power t minus e power t plus 1. Means therefore L inverse of 1 by s into s minus 1 whole square is equals to, if I bring e power t common, 1 t minus 1 plus 1. T minus 1 plus 1. Okay. T minus 1 T minus 1 plus 1. This is. Okay. Next, convolution product. Now, convolution theorem. It's a very important one, convolution theorem. It's a very important one. Convolution theorem is very important theorem. Okay. What is saying now? If L inverse of f bar of s is equal to f of t and L inverse of g of bar of s is equal to g of t, means inverse Laplace transform of f bar of s is f of t, inverse Laplace transform of g bar of s is equal to g of t, then L inverse of f bar of s into g bar of s equals to f of t star g of t. F of t star g of t. Here star is convolution product. Star representation is convolution product. Right? So this convolution product means the convolution product of f of t g of t, we can say. The convolution product of f of t g of t. Where the convolution product of f of t g of t is defined by integration 0 to t f of u into g of t minus u into du. So this is the definition. Okay. So using this, we are going to solve the problems. Under convolution theorem, there is definitely one sum on university examination. Okay. So let us see one problem here. So find L inverse of s by s square plus a square whole square. Means here, L inverse of s by s square plus a square into 1 by s square plus a square. L inverse of s by s square plus a square whole square, I am writing as L inverse of s by s square plus a square into 1 by s square plus a square. Right. So here I am taking, let us take f bar of s equals to s by s square plus a square. Let us take f bar of s equals to s by s square plus a square. Then g bar of s equals to 1 by s square plus a square. You take like this. Because as convolution product says, L inverse of f bar of s into g bar of s means L inverse of f bar of s into g bar of s, where f bar of s means this and g bar of s is this. Now, as per that L inverse of f bar of s is equal to f of t and L inverse of g bar of s is g of t. So that you have to find f of t, g of t you have to find. Means L inverse of f bar of s is equals to L inverse of s by s square plus a square. So L inverse of f bar of s is f of t. L inverse of s by s square plus a square is cos a t. Okay. Similarly, L inverse of g bar of s is equals to L inverse of 1 by s square plus a square. That is g of t equals to a means sin a t by a, sin a t by a. As per the standard formulas of inverse Laplace transform, we write this as sin a t by a. Okay, f of t, g of t we evaluated. Now, L inverse of f bar of s dot g bar of s is equals to f of t star g of t. Okay, by convolution theorem product. By convolution theorem we have this. So from this we write f bar of s dot g bar of s equals to L of f of t star g of t. You can also write like this. Okay. So now I am going to apply that one. So of course this is not required. Okay. This is not required. This is not required. You can have this one and you proceed. Have this one and proceed. Now, which is equals to means f of t star g of t, where f of t star means came as from L inverse of f bar of s dot g bar of s. So which is equals to, by definition of integration 0 to t f of u g of t minus u into du. As per the convolution theorem definition, f of u g of t minus u du, where f of t means cos a t, f of u means cos a u. You can write integration 0 to cos a u. F of u means cos a u, since f of t is cos a t. G of t means sin a t by a. So g of t minus u means sin of t minus u by a into du. Okay. Now here you multiply by 2 and divide by 2. Integration 0 to t 2 cos a u sin a. I have to write a here, a into t minus u. So sin a t minus a u by a, means by a I will bring out. Okay. So 2 cos a sin b, 2 cos a sin b formula. 2 cos a sin b formula. Sin of a plus b means sin of a plus b. A is au, B means AT minus AU, sin of A plus B, sin of A plus B minus, sin of A plus B minus sin of A minus B, minus sin of A minus B. A minus B means AU minus of AT minus AU is going to be 2AU minus AT. Okay, 2AU minus AT into DU. Okay, 2 cos A sin B is sin of A plus B minus sin of A minus B. That formula I applied. So which is equals to 1 by 2A into integration 0 to t. You write this as sin AT, since AU minus AU plus AU get cancelled. Okay, minus sin 2AU minus AT into du. Okay, so which is equals to 1 by 2A. Now I am going to evaluate integration. Sin AT is a constant, sin AT into du, because here integration with respect to u. So sin is a term which is independent of u. So sin AT will be constant and du integration is u. So which becomes sin AT into u minus sin of 2AU minus AT integration. Sin integration is minus cos. So it becomes plus cos. Okay, sin integration is minus cos. So plus cos of 2 minus AU, 2AU minus AT by 2A you will get over the limits 0 to t. Y means here sin 2AU, because this is the only integration part. So sin of 2AU is minus cos 2AU by 2A. Sin AX integration is minus cos AX by A. So similarly sin of 2AU minus AT is going to be minus cos 2AU minus AT by 2A. That is what I wrote. So which is equals to 1 by 2A. I am applying upper limit. So sin AT into t plus, for upper limit, cos 2AT minus AT. For upper limit t now, in the place of u, if I keep t, 2AT minus AT is AT. So this is for upper limit minus lower limit. In the place of u, if I keep 0, the term is going to be 0. Even here also, in the place of u, if I keep 0, 2A into 0 is 0. 0 minus AT is minus AT. Cos of minus AT is cos AT by 2A. Cos AT by 2A. So even here also by 2A will come. Sorry, I forgot. Cos AT by 2A. Okay. So these two terms get cancelled. So only what is left? T by 2A into t by 2A into sin AT. Okay, t by 2A into sin AT. That's all. So this is therefore means inverse Laplace transform of s by s square plus a square whole square, s by s square plus a square whole square is equals to t by 2A into sin AT. So by convolution theorem we solved, by convolution theorem. Okay. Next sum, which is very important. Using convolution means this type of equations, solve the integral equation by Laplace transform he is asking. Solve the, means nowhere he mentioned about convolution at all. solve this equation by Laplace transform. Let us see how that Laplace transform convert into. So here this is y of t equals to a into sin t minus 2 into integration 0 to t y of u into cos of t minus u du. This is the integral equation given. Now I am taking Laplace transform on both sides. Then it becomes L of y of t. I am directly taking Laplace transform for every individual term by applying, by taking linearity property, inverse Laplace transform of linearity property. I am writing this as a into L of sin t minus 2 into what do you write, L of integration 0 to t y of u into cos of t minus u du. I am taking Laplace transform for every individual term separately. Means separately I am taking Laplace transform as per the linearity property of Laplace transform. So L of y of t I am writing as it is, which is equals to a into Laplace transform of sin t is 1 by s square plus 1, okay, minus 2 into, this is L of, what do you write all this one, L of y of t star cos t. Can we write this way? Because it's a convolution product definition. No? As per the convolution product, I can write y of t stars cos t. See here, convolution product theorem. See, f of t star g of t means f of u into g of t minus u. In that sense, I am writing this as y of t star g of t. Okay, so which is equals to L of y of t equals to a into 1 by s square plus 1 minus 2 L of y of t star g of t cos t. See, L inverse of f bar of s dot g bar of s is equals to f of t star g of t. F of t star g of t. If I bring L inverse that side, it becomes f bar of s dot g bar of s. F bar of s means L of y of t into L of cos t. This is f bar of s into g bar of s. Okay. L inverse means L of f of t star g of t is going to be f bar of s dot g bar of s, where f bar of s means L of f of t means y of t into L of g bar of means g bar of s means L of g of t means cos t. So then I will here L of y of t minus a by s square plus 1 minus 2 into, so here L of y of t I will write here because there is no further simplification. L of cos t means s by s square plus 1 we can write. So this term, this L of y of t term I will bring this side. So then 1 plus 2s by s square plus 1 will become L of y of t. When I bring minus 2s by s square plus 1 into L of y of t, if I bring this side, it becomes 1 plus 2s by s square plus 1 into L of y of t is equals to what you left here, is equals to what it left here, a by s square plus 1 is equals to a by s square plus 1. Now you simplify this. When I take LCM and simplify, you will get s plus 1 whole square by s square plus 1 into L of y of t. isn't it? If s square plus 1 goes to here, s square plus 1 plus 2s is nothing but a square plus b square plus 2ab form. That is going to be a plus b whole square by the denominator as it is equal into L of y of t is equals to a by s square plus 1. Now I am taking this to that side, then L of y of t equals to, then L of y of t equals to a by s square plus 1 into, when I bring this fraction to right hand side, that will be reciprocated, that s square plus 1 by s plus 1 whole square, where s square plus 1 numerator denominator get cancelled. Okay, so L of y of t is equals to a by s square plus 1 whole square. So then y of t equals to L inverse of a by s plus 1 whole square. Now you simplify this. So then y of t is equals to, a is a constant with respect to inverse Laplace transform, so that I am bringing outside, and L inverse of 1 by s plus 1 whole square you will get. So which is equals to a into this s plus 1 changes to s by taking out e power minus t by first shifting theorem, 1 by s square, L inverse of 1 by s square, which is equals to a into e power minus t into L inverse of 1 by s square is t. So which is equals to a into t into e power minus t. This is what? Solution of the integral equation, that is y of t. Okay, so this is the way of finding solution for the integral equation by using Laplace transform. I have taken the Laplace transform, but in middle I used what convolution theorem I used here. This part I have used convolution theorem. By convolution theorem, you can also write by convolution theorem. Okay. Next question, even this also. See, y of t equals to 1 minus e power minus t plus integration 0 to t y of t minus u into sin u du. Now take Laplace transform on both sides. Then L of y of t is equals to L of 1. For individual terms, I will take Laplace transform as per the linearity property, plus L of integration 0 to t y of t minus u into sin u du. Okay, so L of y of t L of 1 is 1 by s. L of e power minus et is 1 by s plus 1. 1 by s plus 1 plus, and this is what? Y of t star sin t. L of y of t star means this is a convolution product definition. Okay, L of f of y of t star sin t. So then we write this as L of y of t equals to 1 by s by 1 by s plus 1 plus L of y of t star means convolution product of y of t and sin t is going to be L of y of t into L of sin t. This is happened by convolution product, by convolution theorem. Convolution theorem. product and theorem. And these two steps I followed by convolution theorem and convolution product, right? So now, so L of y of t is equals to 1 by s, otherwise you can simplify this, If I simplify, what do you get here? Directly, s plus 1 minus s is going to be 1 by s into s plus 1 plus, here L of sin t is 1 by s square plus 1, 1 by s square plus 1 into L of y of t. So this L of y of t term I will bring this side, so then it becomes 1 minus 1 by s square plus 1 into L of y of t. 1 minus 1 by s square plus 1 into L of y of t is equals to, on right hand side is left to only 1 by s into s plus 1. Okay, so when I simplify this, what do you get? S square plus 1 minus 1 is going to be s square by s square plus 1. That's all only now. Into L of y of t is equals to 1 by s into s plus 1. So then L of y of t equals to 1 by s into s plus 1. So when I take s square by s square plus 1 that side, it will be get inverted, that is s square plus 1 by s square plus 1 by s square. So L of y of t equals to, on simplification, s square plus 1 by s cube into s plus 1. S square plus 1 by s into s square is s cube into s plus 1. So now I will simplify this. S square by s cube s plus 1 means 1 by s into s plus 1 plus this will be simplified by 1 by s cube into s plus 1. So this is L of y of t. Okay. Now y of t equals to L inverse of 1 by s into s plus 1. For a individual term I am directly writing. L inverse of 1 by s cube plus s plus 1. S cube into s plus 1. S cube into s plus 1. Okay. Now here, so its inverse Laplace transform of these will be evaluated by partial fractions. It's better. Instead of applying, even for this you can apply convolution, but it's taking much calculation and all. Better you go for partial fractions, which is equals to L inverse of 1 by s into s plus 1. How I am writing na? 1 by s minus 1 by s plus 1 I can write. 1 by s into s plus 1 we can write like this, plus L inverse of this 1 by s cube into s plus 1 needs some calculation and all. That is a by s. As I said, rules for evaluating partial fractions, rules for decomposition of fractional fractions, I said already, as s cube is there, so a by s, b by s square and c by s cube. This is the linear term with repetition. S cube is a linear term with repetition. So that I am taking a by s plus b by s square plus c by s cube plus d by s plus 1. So here I will evaluate what is A, what is B and what is C. So for this I will evaluate here. So here I will evaluate what is A and all. So here for this purpose means when I am taking a LCM and all, so A s square into s plus 1 plus bs into s plus 1 plus otherwise so this part I will do. So when I take here a s square into s plus 1 plus bs into s plus 1 plus c into s plus 1 plus ds cube is equals to 1. How this is happened na? So the LCM of these is going to be s cube into s plus 1, where the denominator of a is s. So when I make s to the denominator, the left term is s square into s plus 1. Similarly for B, for C and for D. This rule you are all aware of. Okay. Now I have to evaluate A, B and C. Here simply put s is equal to 0. Put s is equal to 0. What you will get? Only C term will be left. All are going to be 0. C into s plus 1. 0 plus 1 means C. From this you will get, put C is equal to 0, you will get C is equal to 1. Put s is equal to minus 1. Put s is equal to minus 1. So what do you get? If I put s is equal to minus 1, this term is going to be 0, this term is going to be 0, this term is going to be 0. So d into minus 1 whole cube is minus d is equal to 1. That is d is equal to minus 1. From this d is equal to minus 1 you will get. Okay. Now I will take s cube coefficient. Now by putting s is equal to 0, but by putting s is equal to minus 1, I evaluated s, c and d. But I have to evaluate a and b now. For that I am taking another method, s cube coefficients, taking s cube coefficients on both sides. Taking s cube coefficients on both sides. So what is s cube coefficient here? A and d we have. But here on right hand side only we have one. S cube term is not there, so we will take as 0. Where d is equal to minus 1. Where d is equal to minus 1. So then a equals to minus d. So from this a equals to 1 we get, as d is 1. Now next s square coefficient you take. If I take s square coefficient, then as square means a. In this bs square means b, s square coefficient, plus that's all only. Okay. So only a plus b is equals to 0. Here we don't have any s square term on right hand side, it is going to be 0. So from this a equals to b equals to minus a, where a is 1. So therefore b equals to minus 1. So a value, b value and c, d we evaluated. Okay. We evaluated all this. I just taken the partial fraction. So therefore L inverse of 1 by s minus 1 by s plus 1 plus L inverse of a means how much we got? 1 by s. B means how much we got? Minus 1 by s square. Minus 1 by s square. Plus c is how much? 1 by s cube. And d is minus 1 by s plus 1. Okay. So now I will write inverse Laplace transform for every term. L inverse of 1 by s minus L inverse of 1 by s plus 1 plus L inverse of 1 by s. So here we have minus now, plus into minus is minus, L inverse of 1 by s square, okay, plus L inverse of 1 by s cube minus plus into minus minus L inverse of 1 by s plus 1. Okay, so L inverse of 1 is 1 by s is 1 minus L inverse of 1 by s plus 1 is e power minus t. These are all standard formulae. Plus L inverse of 1 by s is 1 minus L inverse of 1 by s square is t minus t. Okay, plus L inverse of 1 by s cube t square by 2. L inverse of uh, L inverse of actually L of t power n is what? N factorial by s power n plus 1. So when I take that side, so L inverse of 1 by s power 1 by s power n plus 1 equals to n factorial by t power n by n factorial. T power n by n factorial. So t power n by n factorial. So t power n by n factorial. That formula I use. Here n is 2. In the place of s plus 1, we have n plus 1, we have 3. So n is equal to 2. So that is t square by 2 factorial. T square by 2 factorial. Minus L inverse of 1 by s plus 1 is again going to be e power minus t. So here plus plus 1, wait. So here, so 1 plus 1 is 2, minus e power minus t, minus e power minus t, minus 2 e power minus t, and minus t plus t square by 2 factorial. Wait, here any mistake happened? L inverse of what is b, what is a is 1 only, na, right? Okay. So which is equals to, is it correct? L inverse of a is equals to, a equals to, a is d is minus 1, a is equal to 1, and b equals to minus a. So then b equals to minus 1. So we'll get, that's all. Okay, that's all. So which is equals to what? Y of t. Right? So this is the way of solving problems under using convolution theorem. Now, it's very important solving differential equations with constants, with constant coefficients. Let us consider the differential equation like this. Nth derivative of y plus a1 into n minus 1 the derivative of y plus a2 into n minus 1 the derivative of n minus 2th derivative of y plus and so on plus yn is an into y is equals to f of t. So here how we take now? To take the Laplace transform, this is the given differential equation. For this take you Laplace transform. Okay. And take the Laplace transform derivatives formula. Okay, Laplace transform derivatives formulas we have L of y dash of t equals to s into L of y of t minus y of 0. Laplace transform derivatives. And Laplace transform y double dash of t equals to s square into L of y of t, L of y of t minus s into y of 0 minus y dash of 0. And Laplace transform y triple dash of t is equal to s cube into L of y of t minus s square y of 0 minus s into y dash of 0 minus y double dash of 0 and so on. So take these Laplace transform derivatives formula and you take the whatever the initial conditions provided in the problem and proceed for evaluating, means solving differential equation. Okay. So first step is you take the differential equation. For that differential equation, take Laplace transform and apply these formulas. Laplace transform derivatives formulas you apply and take the initial conditions and proceed for solving. So let us go for one problem under solving differential equation with constant coefficients. Right. So now I am taking, this is the given differential equation with initial condition. These are the initial conditions. Now I am taking Laplace transform. Now I am taking the Laplace transform. So L of y double dash plus 4y is equals to 0. So this I am writing as L of y double dash plus 4 into L of y. Laplace transform of second derivative formula is s square into L of y minus s into y of 0 minus y dash of 0 plus 4 into L of y is equals to 0. Now you take L of y terms under common part, that is s square plus 4. S square plus 4 into L of y minus y of 0 is how much? 1. S into 1 is s. Y dash of 0 is 6 is equals to 0. So L of here s square plus 4 into L of y is equals to s plus 6 we can write if I bring that side. So then L of y equals to s plus 6 by s square plus 4. L of y equals to s by s square plus 2 square. 6 by s square plus 2 square. So then L of y equals to, or y equals to L inverse of s by s square plus 2 square plus 3 into L inverse of 2 by s square plus 2 square we can write. Because 6 is there, na? 6 can be written as 3 into 2. That 3 I just bring out, and remaining 2 I kept inside for evaluating inverse Laplace transform. This becomes sin 2t plus this becomes 3. This is cos 2t, sorry. This is cos 2t this is cos 2t plus 3 sin 2t. So this is y of t. This is solution of given differential equation. Using Laplace transform, how we are solving under the given conditions. Right? See, I am taking for the given differential equation, I am taking Laplace transform, and Laplace transform derivatives formula I applied, and I took the initial conditions were provided by y of 0 is equal to 1, y dash of 0 is equal to 6, so that I substituted and solved. Okay. Next one. Here, this I will write as d square x by dt square. I am writing as x double dash minus 4 into x dash. dy by dx I am writing as dx by dt I am writing as x dash minus 12x is equals to e power 3t. Okay. Now I will take, this is the given differential equation. Now I am taking Laplace transform on both sides. Laplace transform on both sides. So then L of x double dash minus 4 x dash minus 12x is equals to L of e power 3t. Okay. So now I will take Laplace transform for every individual terms. So L of x double dash minus 4 into L of x dash minus 12 into L of x is equals to L of e power 3t by formula, means by standard formula, Laplace transform standard formula, that becomes 1 by s minus 3. 1 by s minus 3. Okay, Laplace transform of second derivative is s square into L of x minus s into x of 0 minus x dash of 0. This is L of x double dash minus 4 into L of x dash s into L of x minus x of 0. This is L of x dash minus 12 into L of x is equals to 1 by s minus 3. Okay, I applied Laplace transform derivatives formula. Now I am going to take the initial conditions. What are the initial conditions? X of 0 is equal to 1, x dash of 0 is equal to minus 2. So s square L of x, otherwise first I will write, okay, a square into L of x minus x of 0 is 1, 1 into s is s, x dash of 0 is minus 2, means plus 2 it becomes, minus 4 into s into L of x minus x of 0 is 1 minus 12 L of x is equals to 1 by s minus 3. Now I will take L of x common, s square minus 4s minus 12 you will get s square minus 4s minus 12 into L of x, L of x. Okay, so these terms went off under common. Then what is left? Minus 4 minus s plus 2 plus 4 plus 6 minus s plus 6 is equals to 1 by s minus 3 is there. On simplification we are getting like this. Okay, s square minus 4s minus 12 into L of x right. So and minus s plus 2 plus 4 is minus s plus 6. So then s square minus 4s minus 12 into L of x is equals to 1 by s minus 3 minus 6 plus minus s plus 6 that side, if I bring that side it becomes plus s minus 6. Okay, plus s minus 6. Now you can factorize it, s square minus 4s minus 12. On factorization you will get minus 6 s minus 6 into s plus 2 into L of x is equals to 1 by s minus 3 plus s minus 6. Okay, s into s square minus 6s plus 2s is minus 4s, minus 6 into plus 2 is minus 12. So likewise you can factorize s square minus 4s minus 12 directly you factorize like that. Okay, so then L of x is equals to, when I bring these factors to that side it becomes as 1 by s minus 3. It is under multiplication, these factors is under multiplication on LHS. When I bring to that side it becomes divide and s minus 3 into s minus 6 into s plus 2 plus s minus 6 by s minus 6 into s plus 2 is going to be 1 by s plus 2. 1 by s plus 2. So then x equals to L inverse of what do you get? 1 by s minus 3 into s minus 6 into s plus 2. Just I am taking inverse for the inverse Laplace transform for individual terms directly. So L inverse of 1 by s plus 2. Now here again I need to apply partial fraction, which is equals to L inverse of a by s minus 3, b by s minus 6 plus c by s plus 2 plus L inverse of 1 by s plus 2 by inverse Laplace transforms standard formulas, you will get e power minus 2t. From standard formulas of inverse Laplace transform, you will get e power minus 2t. Means L inverse of 1 by s plus a is e power minus at. How na? Similarly, now I have to evaluate what partial fractions a, b, c. So let us see here how we evaluate. Again, a into s minus 6 into s plus 2, a into s minus 6 into s plus 2. Because the total LCM is s minus 3 into s minus 6 into s plus 2. With respect to a, its numerator becomes relief, means without s minus 3 you write the remaining terms of the LCM, plus b into s minus 3 into s plus 2 plus c into s minus 3 into s minus 6, s minus 3 into s minus 6, which is equals to how much? 1. Okay, which is equals to 1. Now put s equals to, so here put s equals to 6. If I put s is equal to 6, what happened? Next page. Okay, a into s minus 6 into s plus 2 plus b into s minus 3 into s plus 2 plus c into s minus 3 into s minus 6, s minus 3 into s minus 6 is equals to 1. Okay, so now I am doing here as looking very small there, so I am taking next page. So here put s is equal to 6. If I put s is equal to 6, a term is going to be 0, c term is going to be 0, only b term will be left. So from this 6 minus 3 means 3, 6 plus 2 is 8, 3 into 8 24, 24b is equals to 1. From this b is equals to 1 by 24. Next, put s is equal to minus 2. If I put s is equal to minus 2, this term 0, only c term will be left. C into 2 minus 3 is minus 2 minus 3 is minus 5, and minus 2 minus 6 is minus 8. Minus 5 into minus 8 is 40, 40c. 40c is equals to 1. From this c is equals to 1 by 40. 1 by 40. So still we required a. So for that, put s is equal to 3. Put s is equal to 3. What do you get here? If I put s is equal to 3, these two terms are going to be 0. Then a into 3 minus 6 is minus 3. Minus 3 into 3 plus 2 is 5. Minus 3 into 5 is minus 15a. Minus 15a is equals to 1. From this a equals to minus 1 by 15. So these are a, b, c values we evaluated for getting partial fractions. Now then x equals to L inverse of a is how much we got? Minus 1 by 15 into 1 by s minus 3. Okay, a into 1 by s minus 3 plus b into 1 minus plus b is how much? 1 by 24 and 1 by s minus 6, 1 by s minus 6. Next plus c is 1 by 40, 1 by 40 is 1 by s plus 2, by s plus 2. So which is equals to minus 1 by 15 L inverse of 1 by s minus 3 plus 1 by 24 L inverse of 1 by s minus 6 plus 1 by 40 L inverse of 1 by s plus 2. Means L inverse of the total is going to writing as L inverse of the individual terms by multiplying the corresponding constant values. This is happened by linearity property. So which is equals to minus 1 by 15. L inverse of 1 by s minus a is e power at. So L inverse of 1 by s minus 3 means e power 3t plus 1 by 24, 1 by 24, and one more thing here, plus e power minus 2t is there, na? That I have to write actually, plus e power minus 2t, plus e power minus 2t I have to write. So this term, okay. So L inverse of 1 by s minus 6 means e power 6t plus 1 by 40 into L inverse of 1 by s plus 2 is e power minus 2t plus e power minus 2t. Okay, so which is equals to minus 1 by 15 into e power 3t plus 1 by 24 into e power 60 plus 1 by 40 into 1 by 40 e power minus 2t plus e power minus 2t is going to be 41 by 40 into e power minus 2t. This is the solution for the given differential equation. This is the solution for the given differential equation. Right? Two minutes break. 2 minutes break. We will continue after 2 minutes. Okay. Okay, students, we will continue for the next problem. This is even this also very simple as we discussed in previously. So this I will write as y double dash y double dash, d square y by dt square I am taking as y double dash, plus 3 dy by dt means y dash, plus 2y is equals to e power minus t. This is the given differential equation. For this I am taking Laplace transform on both sides. So then L of y double dash plus 3y dash plus 2y is equals to L of e power minus t. Okay. Now I will take a Laplace transform for every individual term. So L of y double dash plus 3 into L of y dash plus 2 into L of y is equals to 1 by s plus 1 we can write. Right. This is L of e power minus t means 1 by s plus 1. Standard formula of Laplace transform. L of e power at minus at equals to 1 by s plus a. Similarly, 1 by s, L of e power minus at is 1 by s plus 1. So Laplace transform derivative formula s square into L of y minus s into y of 0 minus y dash of 0 plus 3 into L of y of dash means s into L of y minus y of 0. This is Laplace transform first derivative. This is Laplace transform second derivative. Plus 2 into L of y is equals to 1 by s plus 1. Okay. Now I will substitute the conditions where y of 0 is equal to 0. Where y of 0 is equal to 0. So y of 0 is equal to 0 means that value is going to be 0. This value is going to be 0 totally. And even this also going to be 0. Y of 0 is equal to 0. So the terms are going to be absent. So then s square what happened? S square L of y, this term is going to be 0, minus y dash of 0 is 1 minus 1 plus 3s L of y, so that is 0 plus 2 into L of y is equals to 1 by s plus 1. Okay. Now I will take L of y common. The terms which are with the L of y terms I will take under a common group. S square plus 3s plus 2. S square plus 3s plus 2 into L of y. S square plus 3 plus 2. Next minus 1 only left is equals to 1 by s plus 1. Okay, so we write this as s plus 1 into s plus 2. We can factorize. S square plus 3s plus 2 we can factorize as s plus 1 into s plus 2 L of y. When I bring minus 1 that side, it becomes 1 by s plus 1 plus 1. So then s plus 1 into s plus 2 into L of y is equals to s plus 2 by s plus 1 you will get on simplification. 1 by s plus 1 plus 1 becomes s plus 2 by s plus 1. So then L of y is equals to s plus 2 by s plus 1 into s plus 1 into s plus 2. So s plus 2 get cancelled. Because here under multiplication on left hand side, if I bring that side, it goes to denominator, means goes to under division. So then L of y equals to 1 by s plus 1 whole square. Okay, so then y equals to L inverse of 1 by s plus 1 whole square. Okay, then y equals to, which by first shifting theorem of inverse Laplace transform. By first shifting theorem of inverse Laplace transform, we can write e power minus t into L inverse of 1 by s square. S shifted to s plus 1 shifted to s by taking out e power minus t on first shifting theorem. So which is equals to e power minus t Laplace inverse Laplace transform 1 by s square is t, standard Laplace transform. That equals to t into e power minus t. This is y of t. Okay. Next, so very important one, d square x by dt square plus 9x is equal to sin t. D square x by dt square plus 9x is equals to sin t. So this here d square x by dt square I am writing by x double dash 9x is equal to sin t. Now I am taking Laplace transform throughout the differential equation. Then L of x double dash plus 9x is equals to L of sin t. Okay, L of x double dash plus 9 into L of x is equals to 1 by s square plus 1. L of sin t is 1 by s square plus 1. L of x double dash Laplace transform derivatives formula s square into L of x minus s into x of 0 minus x dash of 0 plus 9 into L of x is equals to 1 by s square plus 1. Okay, now L of x I will take common and I will apply the conditions. X of 0 is equal to 1. Okay, s square plus 9. S square plus 9 into L of x. These two terms only under L of x terms. Under L of x. X of 0 is 1. So minus s into 1 minus s. Minus s. Next x dash of 0. Here this is in the means with respect to first. Means with respect to first question. With respect to first question. Here x dash of 0 is equal to 1 provided. X dash of 0 is equal to 1 provided. X of pi by 2 is provided as 1. So these only given. So with respect to first condition I am evaluating this. Okay. Which is s minus x dash of 0. So we don't have x dash of 0. So let us take this as a. X dash of 0 I am assuming as a, that value I don't know, so I am taking as a is equals to 1 by s square plus 1. So here let x dash of 0 is equals to a. Is equals to a. Right. So now s square plus 9 into L of x is equals to 1 by s square plus 1. You take minus s minus a that side plus s plus a it becomes. Okay. Now you take a s square plus 9 that side, then it becomes 1 by s square plus 1 into s square plus 9 plus s by s square plus 9 plus a by s square plus 9. Because s square plus 9 if I take to that side, it goes to be under division to every term. In that sense I am writing by s square plus 9 to every term. So now you take L that side, then L inverse of 1 by s square plus 1 into s square plus 9. Directly I am taking L inverse to every individual term by linearity property by s square plus 9 plus a into L inverse of 1 by s square plus 9. Okay. So which is equals to. So here for evaluating inverse Laplace transform I need to apply partial fractions. So this I am directly writing by 1 by s square plus 1 minus 1 by s square plus 9. I am writing this directly because the difference, this is also s square term, s square term factor, and this is also in terms of s square term factor. So whose difference is 8. So I can divide by 8 because if I simplify, the numerator is going to be 8. That will be get balanced by dividing by 8. Okay. On splitting into partial fractions, the numerator will be getting by 8. That will be get balanced by dividing by 8. Okay. So then plus L inverse of 1 by L inverse of s by s square plus 3 square plus a into L inverse of 1 by s square plus 3 square. Okay. Now, so which is equals to x is equals to 1 by 8. We'll write outside L inverse of 1 by s square plus 1 means L inverse of 1 by s square plus 1. L inverse of 1 by s square plus 1 minus L inverse of 1 by s square plus 3 square. Next, L inverse of s by s square plus 3 square is cos 3t, that is cos 3t plus a into sin 3t by 3. L inverse of 1 by s square plus a square is sin a t by, like that, sin 3t by 3. So here we write as 1 by 8. L inverse of 1 by s square plus 1 is sin t minus sin 3t by 3 plus cos 3t plus a by 3 sin 3t. This is x of t we got. But in this solution we have the unknown value a. This value we don't know. We have to find by using the condition x of pi by 2 is equals to 1. X of pi by 2 is equals to 1. So means x of pi by 2 is equals to 1 by 8 sin pi by 2 minus sin 3 pi by 2 by 3 plus cos 3 pi by 2 plus a by 3 into sin 3 pi by 2. Okay, I am just putting t by pi by 2. X pi by 2 is 1 is equals to 1 by 8 and sin pi by 2 is 1 and sin 3 pi by 2 is minus 1 and by 3 means plus 1 by 3 you will get here plus cos 3 pi by 2 is cos minus pi by 2, cos of cos pi by 2 minus cos pi by 2 is going to be 0 plus sin 3 pi by 2 is minus 1 means here minus a by 3. So this is minus a by 3 minus a by 3. Okay. So which is equals to 1 by 8 into 4 by 3 minus a by 3. So which is equals to 1 by 6. 1 by 6 minus a by 3. From this, minus a by 3 equals to 1 minus 1 by 6. Minus a by 3 equals to 5 by 6. Minus a equals to 5 by 6 into 3. A equals to minus 5 by 2. Minus 5 by 2. That you substitute. So therefore, x of t equals to I evaluated a value that I am going to substitute. 1 by 8 into sin t minus sin 3t by 3, okay, plus cos 3t plus a is minus 5 by 2 by 3 means minus 5 by 6, minus 5 by 6 into sin 3t. So which is equals to 1 by 8 into sin t minus sin 3t by 3 plus cos 3t minus 5 by 6 sin 3t. This is the solution of given differential equation. With respect to first one. Second question. What is the second question provided here? Under second, x of 0 is equal to 1, x dash of 0 is equal to 0. X of 0 is equals to 0, x dash of 0 is equal to 1, is it? X of 0 is equal to 1, x dash of 0 is equal to 0, sorry. And this is 1, means 1. So now, for applying this condition, what I have to take now here? So here, this condition I have to take, I'm sorry. So this I have to take, okay. This form means this one in this question 1, in the equation 1, I applied the first conditions. For the second one, I have to take that equation 1 we can write from 1 what we have s square into L of x, otherwise you can write directly s square plus 9 into L of x, s square plus 9 into L of x minus s into x of 0 minus s into x of 0 minus x dash of 0 is equals to what we have? 1 by s square plus 1. 1 by s square plus 1. This I wrote from equation 1. S square plus 9 into L of x minus s into x of 0 minus x dash of 0. So in this I am going to substitute s square plus 9 into L of x minus x of 0 is 1, s into 1 is s, x dash of 0 is 0. So is equals to 1 by s square plus 1. Okay. So s square plus 9 into L of x is equals to 1 by s square plus 1 plus s. I am just taking minus s that side. So then it becomes L of x equals to 1 by s square plus 1 into s square plus 9 plus s by s square plus 9. S by s square plus 9. Okay. Then L of x, you apply partial fractions, you will get 1 by 8 because whose difference is 8. So 1 by s square plus 1 minus 1 by s square plus 9 on partial fractions by s square plus 9 means 3 square. So L of x means x equals to, x of t equals to 1 by 8 into 1 by s square plus 1 square minus 1 by s square plus 3 square plus s by s square plus 3 square under L inverse. So then which is equals to 1 by 8 into L inverse of 1 by S square plus 1 square minus L inverse of 1 by S square plus 3 square under 1 by 8. This total is under 1 by 8 plus L inverse of 3S by S square plus 3 square. Okay, so which is equals to 1 by 8 into L inverse of 1 by S square plus 1 by S square plus 1 square is going to be sin t minus L inverse of 1 by S square plus 3 square is going to be sin 3t by 3 plus cos 3t. This is x of t. This is x of t. Okay, so this is the problem which I discussed. Next is variable coefficients. Next is variable coefficients. Okay, t into d square y by dx square plus 1 minus 2t into dy by dx minus 2y is equal to 0. Means t into x double dash means differential equation with variable coefficients. It is previously with the constant coefficients we discussed, variable coefficients. T into x double dash plus y double dash. T into y double dash y dash 1 into dy by dx means y dash minus 2 into t. T means ty dash minus 2y is equals to 0. Okay. Now I am taking Laplace transform L of t into y double dash plus L of y dash. I am taking Laplace transform for every individual term directly by 2 into L of t into y dash minus 2 into L of y is equals to 0. Okay. So here multiplication by t rule, Laplace transform under multiplication by 2 rule is you multiply t power 1, so we have to multiply by 1 and d by ds. Different one time differentiation when t is multiplied by when f of t is when the function is multiplied by t, so minus 1 into d by ds of L of y double dash plus, so this is L of y dash only, you write as it is, minus 2 into L of t into y dash. So here multiplication by t, so minus 1 into d by ds of L of y dash minus 2 into L of y is equals to 0. Okay, so here multiplication by 2 rule I applied. Laplace transform under multiplication by 2 rule I applied. Next, minus d by ds minus d by ds L of y double dash. L of y double dash is s square into L of y minus s into y of 0 minus y dash of 0. Okay, minus d by ds of L y double dash I wrote. Next, L of y dash I have to write, L of y dash plus s into L of y s into L of y minus y of 0. S into L of y minus y of 0. Minus 2 into minus 1 plus 2. D by ds of L of y of dash means d by ds of s into L of y of s into L of y of t, L of y of t minus y of 0. Okay, this I wrote minus 2 into L of y is equal to 0. Is equal to 0. Okay. Now we will substitute the conditions minus d by ds s square into L of y. What is y of 0? Y of 0 is 1, y dash of 0 is 2. Y of 0 means s into 0, s into 1 is yes, y dash of 0 is 2. Y dash of 0 is 2 plus s into L of y and y of 0 is 1 plus 2 into d by ds of s into L of y and y of 0 is 1 minus 2 into L of y is equal to 0. So now I will go for finding differentiation here. S square into L of y. Even L of y is a function in S. L of y is nothing but y, f bar of s. So s square into f bar of s. UV rule you have to apply. So s square differentiation minus you write outside 2s into L of y plus s square into d by ds of L of y. Okay. In differentiation of s square into L of y I wrote minus d by ds of s is 1 and d by ds of 2 is going to be 0 plus s into L of y minus 1 plus 2, again d by ds of s into L of y, u by v rule. So here s differentiation 1 L of y plus s into d by ds of L of y minus differentiation of 1 is going to be 0 minus 2 into L of y is going to be 0. Okay. So then you multiply by minus 2s into L of y minus s square d by ds of L of y. So minus into minus plus 1 plus s into L of y minus 1 plus 2 into L of y plus 2s into d by ds of L of y minus 2 into L of y is going to be is equal to 0. Now from these terms, wherever d by ds of L of y terms, these you take into under common. So this one minus s square d by ds of L of y plus 2s d by ds of L of y. You write these two under. So here 2s minus s square into d by ds of L of y. I am writing. Okay. Next L of y terms. L of y terms means minus 2s. Next plus minus 2s plus s minus s. minus s minus 2s L of y plus s L of y is going to be minus s L of y minus s plus 2 L of y minus 2 L of y. These two get cancelled. Okay, so minus s L of y only you get. Minus s L of y is equals to, what are the terms left here? Plus 1 is there and minus 1 is there. Those two also get cancelled, isn't it? Plus 1 and minus 1 is going to be get cancelled. And what terms still left? Okay, that's all. So is equal to 0. So then s into 2 minus s d by ds L of y is equals to s into L of y you get. If I bring s into L of y that side. Okay, so then which is going to be d by ds of L of y is equals to, if I bring that side, if I bring that side, s by s into 2 minus s, s by s into 2 minus s into L of y. S get cancelled. So means d L of y by ds is equals to L of y by 2 minus s you will get. Okay, now apply variable separable formula, means d L of y by L of y is equals to 1 by 2 minus s into ds. Okay, so this is, now you do integration on both sides, you will get log of L of y is equals to minus log of 2 minus s you will get, plus some constant log c. Why I am taking minus log of? Because it is what? 2 minus s, na? It is 2 minus s, not 2 s minus 2. It is 2 minus s. So it becomes 2 minus s, where I wrote the 2 minus s. Okay, so 1 by 2 minus s ds integration is minus log 2 minus s, because s coefficient is minus 1, na? So minus followed here. So log of L of y plus log of 2 minus s is equals to log c. Okay, so then log of L of y into 2 minus s is equals to log c. So then you just cancel log on both sides. Then L of y equals to, so L of y equals to c by 2 minus s. So then y equals to L inverse of c by 2 minus s, which is equals to L inverse of c by s minus 2 followed by minus. I am writing 2 minus s by minus into s minus 2, which is equals to minus L in c, also you bring out L inverse of 1 by s minus 2, which is equals to minus c into L inverse of 1 by s minus a is e power at, means e power 2t. Okay, so y equals to, y of t equals to what? Minus c into e power 2t, or simply c into e power 2t. C is a constant, minus c is also going to be constant, so you can also write c into e power 2t. So this is the way of solving differential equations with variable coefficients. Okay, so just you apply the same thing, but you need to take this part, multiplication by t. Multiplication by t means you have to apply this condition and solve and proceed as usually as we done the problems and the differential equations, how we solve the differential equations. So you proceed. Next, solving system of equations, system of simultaneous equations. This is also one method, last method, system of simultaneous ordinary differential equations using Laplace transform. We have two differential equations here. So dx by dt means x dash, I will write, means x dash minus 2x plus 3y is equal to 0. And another one is y dash plus 2x minus y is equals to 0. These two equations that I will write in the next page. X dash minus 2x plus 3y is equal to 0. And y dash plus 2x minus y is equal to 0. And okay, and what is the conditions provided? X of 0 is equal to 8, y of 0 is equal to 3. X of 0 is equal to 8 and y of 0 is equal to 3. Conditions are provided. Okay, so using these conditions we are going to solve this. Now I am taking Laplace transform for this differential equation. L of x dash, directly I am writing Laplace transform for the given differential equation under linearity property. Okay, so L of x dash means s into L of x minus x of 0 minus 2 into L of x plus 3 into L of y is equal to 0. Okay, now L of x terms you write under single group, that is by taking common, plus 3 into L of y, and x of 0 is provided by 8 na, minus 8, if I bring that side is equal to 8. This is one equation. This is one equation. Next, so for this differential equation I am taking Laplace transform for this differential equation. So L of, directly writing L of y dash plus 2 into L of x minus L of y is equal to 0. L of y dash Laplace transform derivative formula, s into L of y minus y of 0, okay, plus 2 into L of x minus L of y is equals to 0. So now L of y terms means first you write down 2 into L of x and y of terms plus s minus 1 into L of y, s into L of y minus L of y, by taking L of y common, s minus 1 minus a y of 0, y of 0 is 3, minus 3, if I bring that side is equal to 3. So this is second equation, this is first equation. Solving these two first and second equation, we are going to evaluate L of x and L of y. So from first and second equations, I am just applying Cramer's rule. Okay, I think you are all aware of Cramer's rule. So this is ax plus by is equals to c, or a1x plus b1y is equals to c1, a2x plus c2y is equal to c2. Then x formula is what we say. So del 1 by mod del 1. Mod del 1 by means determinant of del 1 by determinant of del, and y equals to determinant of del 2 or del 2 by del. What is del 1? Del 1 means here x coefficients are replaced by constants, and del 2 means y coefficients are replaced by constants. That is what I am going to do here. L of x, L of x. So determinant of, so here x coefficient is s minus 2, here x coefficient is 2 na, s minus 2, here you will get, see I will write here. So what is del now? Determinant of s minus 2 and 2, 3 s minus 1. This is del actually, determinant of x and y coefficients. So here this x coefficient is replaced by constants. Here constant is 8, here constant is 3. So 8, 3, 8, 3, and y coefficient is 3 s minus 1. This is del 1. By del means the determinant. S minus 2, 2, 3 s minus 1. This is for L of x formula. Del 1 by del, del 1 by del. So del 1 means replace x coefficients by constant, by del put the x and y coefficient on the determinant form. Next, L of y. Just Cramer's rule, using Cramer's rule. Del 2. Del 2 means write the x coefficient as it is and replace y coefficients by 8, 3 by s minus 2, 2, 3 s minus 1. Now we try to simplify this. So L of x, so 8 into s minus 1, 8s minus 8 minus 9 means 8s minus 17, it becomes numerator. S minus 2 into s minus 1, s square minus 3s plus 2 minus 6 is going to be s square minus 2s minus s means minus 3s, and minus 1 into minus 1 plus 2 minus 6 is minus 4. Next, L of y, similarly L of y, s minus 2 into 3, 3s minus 6 minus 16, 3s minus 22 will come. 3s minus 22, denominator is same, s square minus 3s minus 4. Again you have to factorize it. L of x, 8s minus 17 by here s square minus 3s minus 4. I think s minus s plus 1 into s minus 4. Okay, its factorization is s plus 1 into s square plus s minus 4 is minus 3s plus 4 into minus 1 is plus 1 into minus 4 is minus 4. So here L of y equals to, even here also s 3s minus 22 by s plus 1 into s minus 4. Okay, now you apply partial fractions and do, which is equals to a by s plus 1, b by s minus 4, L of x. Even here also L of y is equals to a by s plus 1, otherwise c you write down, c by s plus 1, b by s minus 4. So now try to evaluate this partial fraction. Here a into s minus 4 plus b into s plus 1, which is equals to 8s minus 17. Put s is equal to 4. If I put s is equal to 4, this is going to be 0, 4 plus 1 is 5, 5 means 5b, 5b, that implies 5b, 5b equals to 8s means 4 na? 32 minus 17 is 15. So from this b is equal to 3. Next put s is equals to minus 1. Put s is equal to minus 1. If I put minus 1, this is going to be 0. Minus 1 minus 4 minus 5, that is equals to minus 5a is equals to minus 8 minus 17 is minus 25. So from this b is equals to what? 5. So therefore L of x is equals to a is 5 by s plus 1 and a by 5 by s plus 1, 3 by s minus 4. This is. Similarly this one, c into s minus 4 plus d into s plus 1 is equals to 3s minus 22. Put s is equal to 4, then this is going to be 0, 5d, that is 5d equals to 12 minus 22, 10 minus 10. So d is equals to minus 2, isn't it? 5d, 3 into 4 is 12, 12 minus 22 is minus 10, d is equal to minus 2. Next put s is equals to minus 1, then that implies minus 5c is equals to minus 3 minus 22, minus 25, which is equals to c is equal to 5. So therefore L of y equals to what you get? C means how much we got? 5 by s plus 1 and d how much we got? Minus 2 by s minus 4. Okay. So next please, L of x is equal to 5 by s plus 1, 5 by s plus 1 plus 3 by s minus 4. Next L of y equals to 5 by s plus 1 minus 5 by s plus 1 5 by s plus 1 minus 2 by s minus 4. So then x equals to, directly I am writing L inverse of 1 by s plus 1 into 5 plus 3 into L inverse of 1 by s minus 4. So which is equals to 5 into e power minus t. L inverse of 1 by s plus 1 is e power minus t plus 3 into L inverse of 1 by s minus 4 is e power 4t. Okay, this is x and y. Here y equals to L inverse of 5 into 1 by s plus 1 minus 2 into L inverse of 1 by s minus 4, which is equals to 5 into e power minus t minus 2 into e power 4t. This is y. So therefore x of t is equals to 5 into e power minus t plus 3 into e power 4t, and y of t equals to 5 into e power minus t minus 2 into e power 4t. So these are the solutions of given simultaneous differential equations. Okay. So by this Laplace transform unit is completed. Every topic I covered every topic, and mostly I covered all the previous year questions and number of problems I solved on every method, every part, every method, every simple single method also I have discussed. Even I didn't left any method. Everything I covered, you please make it use of these videos. Okay, thank you.